Hey guys, welcome back. We're going to review our properties of parallelograms. If you remember, there's 5 of those properties. We're going to see if we can identify them using them with the markings here. So can we prove that this is a parallelogram? Well, on this diagram, it shows that these diagonals are, they're splitting each other into 2 equal halves, right? So this one cuts that one in half and that one cuts the other one in half. Is that one of our 5 properties of a parallelogram? And it is, so we are able to prove that this is a parallelogram because the diagonals are bisecting each other. Let's look at another one. So these markings are telling us these opposite sides are parallel. The other 2 are saying that they're congruent. We talked about that one, I think, yesterday, and then it also showed up on the homework again. And if you remember on this one, the problem is that it's actually allowed to swing in and still have these sides be parallel and those opposite sides be congruent. So this could be an isosceles trap, so it could be a trap. It's kind of funny. All right, next one here we have opposite sides are congruent. That was one of our properties, so yes, it is a parallelogram because opposite sides are congruent. Here, both opposite sides are parallel. That's, of course, what it means to be a parallelogram. It's kind of like the native definition, I guess you could call it that. Then on this one, we've got 110 and 70 and 70. So this is showing us that the consecutive angles are supplementary, right? So these 2 are same side interior and so are those. And if the consecutive angles are supplementary, that is enough to prove it because that's one of our 5 properties. And then the last one is showing that both opposite sides are going to be congruent because the blue ones are both marked with 1 and the green ones are both marked with 2. And that is, again, one of our properties as well, that the opposite sides are both congruent. So here's our parallelogram family tree. So at the very top we have our parallelogram, and then from that we have a rhombus, a rectangle, and a square. So what makes something a rectangle is that it has 4 right angles. In fact, rect is actually, if you add an H right after the C there, that's actually the German word for right. So like to turn right would be to abbiegen recht. So rectangle is a German word just translated, kind of English Americanizing it by dropping the H. So rectangle in German just reads right angle. So it's right angled figure. And then over here with the rhombus, rhombuses have all 4 sides are congruent. So that's what makes something a rhombus. And then a square is actually kind of like a combination of those 2. So in the family tree, we would have over here, this is the baby daddy rectangle. The reason it's the baby daddy, well, we've already talked about what's in between between the legs of a right triangle. So anyway, that's why it's the baby daddy. And over here you have the baby mama rhombus. And then you have the baby square. Now the baby square gets half of its characteristics, just like biology, right? Half of it from its dad and the other half from its mom. And so it does have 4 right angles from baby daddy. And from baby mama, it's got 4 congruent sides. So there you go. So I guess the parallelogram, I don't know what that would be, like the grandfather, grandma, I don't know. All right, moving on from there. We have different properties of parallelograms, so we'll go through those again. The opposite sides, remember, because of alternate interior angles, the green angles and the blue angles were the same. We also were able to say that this diagonal is congruent to itself. So these triangles were congruent, and so all their corresponding parts had to be congruent as well, meaning that the opposite sides up here, the blue and the green sides had to be congruent. So opposite sides were congruent. We also knew the opposite sides were parallel, right? That's the definition from a parallelogram. Then we have consecutive angles. So the consecutive angles are the ones next to each other. Well, they're same side interior, and so they're going to be same side supplementary. So if this is 120, that has to be 60. Same thing, 60 over here. And then right back to where we started, this one has to be 120, which means the opposite angles have to be congruent. So the consecutive angles are supplementary because they're same side interior. The opposite angles are congruent. Then with the diagonals, we have vertical angles. Those angles are the same on both of them. So what ends up happening is that triangles A and B, not these A and B, but these 2 this time, they have to be congruent, meaning that the diagonals are corresponding parts of congruent triangles, and so they're going to cut each other in half, and so the diagonals bisect each other. All right, so properties of a rectangle. So again, rect is the German word for right. So we have 4 right angles, so that's what the green ones there are for. And the next part is, BC is congruent to itself. So this segment here, BC is going to be congruent to BC. I don't know if I did it. Yeah, there it is. And then AB is congruent to DC. Well, that's because rectangles are parallelograms, so they inherit all the properties of the parallelograms, meaning the opposite sides are going to be congruent like we have here. So BC is congruent to itself by reflexive property, and then AB is congruent to DC because opposite sides are congruent because it is a parallelogram still. And then, I don't know if you can tell the difference between the blue and the orange triangle, so I'm actually going to pull the blue one down here just so you can see better what's going on. BC is still congruent to that one, so, and also this side is still that one right there. So if we look at the blue triangle and the orange one on the top, what do you notice about those two triangles? Well, we have the same side, the same included angle here, and the same side here. We have this same side, the same included angle, and the same side. So we can actually prove that those two triangles are congruent to each other by side, angle, side. And if they are congruent, then that means that their hypotenuses, the corresponding, the longest part on the opposite of the right angle, has to be congruent as well. Meaning these two diagonals, the blue diagonal and the orange diagonal, have to be congruent. So on a rectangle, the diagonals in fact are congruent to each other, which is kind of cool. And I'll actually show that to you demonstrated with GeoGebra here. So I constructed a rectangle. We have AE and DE. If you notice, those are the same. Well, and same thing with CE and BE. Those are the same as well. Now, we already knew the diagonals bisected each other. That was a property of parallelograms. But now in a rectangle, what's interesting is that they're all going to be exactly the same. So no matter how I move this rectangle around, whoa, kind of cool. At any given time, the diagonals are always going to be equal to each other because we have to have 4 right angles. So kind of cool. So for a rectangle, the diagonals are not only bisecting each other, because that's for all parallelograms, but they also are congruent. Okay, then properties of a rhombus. So rhombi are parallelograms with congruent sides, so we have all 4 of the congruent sides. That's going to be the green part here. And then if we draw one diagonal, well, we know that diagonal is congruent to itself, right? Reflexive property. And so we know that these two triangles are congruent, right? So this triangle over here is the same as that triangle. And so what that means is that the base angles have to be the same. Also, if it's isosceles triangle, if we look over here, the base angles have to be the same on an isosceles triangle. So this angle is the same as that angle, and the same thing happens on the others, which is that angle is the same as that angle. So what's happening is this diagonal is cutting the opposite angles in half. It's bisecting the opposite angles. So the diagonals bisect the opposite angles. The same thing is going to happen if I go and delete some of these markings here. The same thing's going to happen if I look at the other diagonal as well. So I kind of showed that part. So here's the other diagonal coming into play. So if I fade that one out. All right. Now the same thing, we have the 2 green sides are the same as those, and the blue side's the same for both of them. So they're congruent by side, 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 meaning these angles have to be the same as well. And they're also isosceles, so base angles are the same. So what's basically the diagonal, the purple diagonal bisects these 2 opposite angles, and the blue diagonal bisects these 2 opposite angles. And then what you might notice on that when they intersect is that these angles in the middle also have to be the same because they have the same sides, because the diagonals still bisect each other as from properties of parallelograms. So we end up with quite a bit going on here. So I'll mark it for you. So those sides bisect each other, these sides bisect each other as well. And so we have 4 different triangles, so I guess I'll label those for you. We have triangle A, we have triangle B, triangle C, and triangle D. And it looks like a P. Try that again. D. There we go. And all 4 of those triangles are exactly the same because they have the same side here, the same diagonals as well. So all 4 of them are the same, and they have the exact same angles. Those angles are the same, these angles are the same thing going on this side. So you can actually fold a rhombus, and in class I'll fold one up, but you can fold it down, you can fold it across this diagonal as well, and you'll end up with the same 4 triangles going all across there. So what's interesting is that the angles in the middle, they all have to be exactly the same, and so they're all having to be 90 degrees because they add up to 360 altogether. So we end up with right angles and perpendicular diagonals in this case. So the diagonals bisect each other with a rhombus, and the diagonals are perpendicular. Essentially, when you have a rhombus, you've got a lot of things going on here. Pretty much everything's congruent. It's either going to be one of the small angles, or it's going to be one of the big angles. So for instance, if I tell you this is, let's say, 70 degrees, then we know all of these angles here have to be 70 degrees. And if we have our triangle and that's 70, it means this part over here has to be 20. And so all of these angles have to be 20. So all of our angles are 20, 70, 90, 20, 70, 90, 20, 70, 90, 20, 70, 90. So pretty easy to solve rhombuses. They're pretty forgiving. Let me show you that one, properties of rhombuses and GeoGebra here real quick. So all the angles in the diagonals are always going to be right angles, and these 2 are the diagonals also bisect the angles. So those are both 30, those are both 60, and then as I move this around here, no matter where I put it, they actually say the same. What's going on? Why are those staying the same? It won't let me define it any other way. Well, that wasn't quite exactly what I was trying to do. I was trying to change the angles, but this is a special, I'll have to change the construction. I used 2 circles on this one, but this is a special one where it is from 2 circles and equilateral triangles. So I'll have to try to figure out another way to define and construct a one. I need it to be able to change this distance here, but I'll have to work on that anyway. But those are always going to bisect each other, and we're always going to have diagonals that are perpendicular in the middle. So the diagonals bisect the opposite angles, and the diagonals are also perpendicular. Those are properties of rhombuses. All right, so here we have our family tree kind of shown out in a tree diagram. Over here we also have it in a Venn diagram. So in the big box, which are all parallelograms, because all these are special parallelograms, we have rectangles and rhombi. And what's interesting, everyone knows that a square is a subset of rectangles, but maybe not that a square is a subset of the rhombuses. So remember, we got our baby daddy rectangle, baby mama rhombus, and then the baby square over here is a combination of both of those. So the properties they actually share from both of them. So they inherit the fact that we've got diagonals that are perpendicular. They inherit that from the rhombus. And the fact that our diagonals are not only bisecting each other, but they're all the same. They're going to inherit that from baby daddy rectangle. They're also going to inherit the right angles from the rectangles and the 4 congruent sides from the rhombus. The other one we have is that the angles are going to bisect each other. So the angles bisecting each other is the exact same. I think I showed it here. Is the exact same thing that's going to happen on all the angles. They're all going to be 45 degrees with a square, as you can imagine. All right, so here's our hierarchy of quadrilaterals. So up here we have just general quadrilaterals, which are going to have 4 sides, right? Oh, I did 40. Anyway, they just have 4 sides. So any weird shape with 4 sides would be a quadrilateral. And then we split it up into kites, which have 0 parallel lines, parallelograms, which have 2 sets of parallel lines, and trapezoids that only have 1 set of, I'm going to do it like the British way, 1 set of parallel lines. And then from there we have an isosceles trapezoid where the trapezoid sides are the same. There's a weird relationship between rectangles and trapezoids. We'll talk about that on Thursday. Scandalous. And between a kite and a rhombus, which normally you wouldn't associate, but there is a relationship between those two as well. Maybe you can guess what it is. We'll talk about that one on Friday, or B days will be 2 days after that, or next week, Tuesday and Wednesday. And then we have the part that we talked about today, which are rhombuses, rectangles, baby mama rhombus, baby daddy rectangle, and the baby square, which are all coming from the parallelogram and some weird relations. What's going on there? I don't. That's a problem for another day. All right, so let's get into the homework. We're going to start out with a pretty big proof here, but we're going to do it together, so we should be just fine. So the first part is that it's a rhombus, and if it's a rhombus, we know all the sides are congruent. Well, that comes from the definition of a rhombus. So I'm just going to mark all the sides congruent. No big deal, so 1, 2, 3, 4. And then CE is going to be the same as BC, or CB. And the reason for that is because it is still a parallelogram. Rhombuses are parallelograms. So the diagonals cut each other in half, right? So AD cut this one in half, so they are. So diagonals bisect each other, no problem. AC is congruent to itself. That's by the reflexive property. And then if you notice, I've got side, 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 side. So these 2 triangles are going to be congruent. It looks like we're also marking that AB is congruent to AE. Well, we're just restating that. That, again, came from definition of a rhombus. And so the triangles are congruent by side, 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 as we said, side, 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 side. All 3 of the sides are the same, so those have to be the same triangles, which we already knew from rhombuses. We're just proving it again. Then angles 1 and 2 have to be the same. The reason for that is their corresponding parts of congruent triangles are congruent. And the same thing with angles 3 and 4. Those are corresponding parts, so they have to be congruent as well. All right, so therefore the diagonals of a rhombus bisect the opposite angles. So angles 3 and 4 they're both going to be congruent. Essentially what it did is this diagonal AD cut this opposite angle in half. It's going to do the same thing down here. Without loss of generalization, we can do the same proof just on the bottom part. All right, then moving on from there, this one's actually kind of intuitive, but this is technically how you do the proof. Angles 1 and 2 are a linear pair. They do add up to 180. That's from a definition of a linear pair. And then if we knew that angle 1 was equal to angle 2, which is what we said earlier, we can substitute angle 1 in for angle 2. So this is substitution. Then combine our like terms. Angle 1 plus angle 1 is going to be 2 times the measurement of angle 1, which is just CLT, or combining like terms. And then we can divide both sides by 2 to leave us with the measurement of angle 1. That's the division property of equality. The measurement of angle 1 has to be 90 degrees. Therefore, the diagonals are all going to be perpendicular to each other. So we know that we have, there is something somewhere in there, isn't there? Yeah, there we go. So therefore, all the angles in the middle are all going to be perpendicular. So the diagonals of a rhombus are perpendicular. All right, so now let's actually fill in our properties here. So what are 4 properties of parallelogram? The one that I'm not stating here is that a parallelogram, the opposite sides are parallel. That's kind of given in a parallelogram. So first one that we have is that the opposite sides are congruent. So we know these sides are going to be congruent, and so are those. We also know the opposite angles are going to be congruent. That's because they are the same supplement. Then we have consecutive angles are supplementary, the ones next to each other because they're same side interior. And the last one is that diagonals bisect each other. Now these 4 properties of parallelograms are inherited by all of the other, the children of the parallelogram, right? So rhombuses, rectangles, and squares, they all have these 4 properties as well. I'm not going to make you list them again because then it would get really, really long. But let's look at the baby mom rhombus. So on this one, the rhombus, we have 3 properties. All the sides are congruent. That's what it means to be a rhombus. And then like with the rectangle, all the sides are right angles. So we have 4 congruent angles. That's what it means to be a rectangle. What's special about a rhombus? Well, the diagonals do 2 things. They're perpendicular and they bisect the opposite angles. So diagonals are perpendicular and they bisect the opposite angles. And then over on the side for the rectangle, what's special about them is that the diagonals are going to be congruent to each other. So they're always going to be exactly the same. And then the square is the byproduct of both of the baby mama rhombus and the baby daddy rectangle. And so it inherits the same properties from their parents, and they also inherit all the properties of the parallelogram. So technically squares have all of these properties here. We're just going to relist the ones from the rhombus and the rectangle. So from its baby daddy rectangle, it gets right angles and congruent diagonals. And then from the rhombus, it gets congruent sides, diagonals that are perpendicular, and the diagonals that bisect the angles. Okay, so quite a bit going on there, but just good for you guys to map all that out. Also, whenever you're doing the homework assignment, if you need to go back to this, you can look at, and it's on your own homework, so you don't have to take a picture or anything. All right, number 2, we want to classify the diagram as the most specific classification that we can. So not just a parallelogram because the opposite sides are congruent, but if you notice all 4 of the sides are the same thing. So this would mean that it would have to be a rhombus because on a rhombus, all 4 sides are going to be congruent. So that is a rhombus. But let me go back. We don't have enough information to say it's a square because we don't know if the baby daddy's a rectangle, right? So it's like an episode of the Maury Show. We don't know who the father is, right? But we do know it's at the very least it's a rhombus, right? All right, on this one we have one set of parallel sides, one set of congruent opposite sides, and then some right angles. All right, well, if we have the parallel sides and the right angle, then these are same side interior supplementary, right? Which mean that has to be a right angle up here. And same thing, the supplement of this also has to be a right angle, just going from the same side interior angles. So we have 4 right angles, which means it's at least baby daddy rectangle, but do we have enough information to prove that it's a square? Well, we would need to know if those sides are the same as these sides, otherwise it's just a rectangle. So the most specific that we can say is that it has to be a rectangle. Then on this one we have opposite sides are parallel, so it's at least a parallelogram. All the sides are the same, so it's at least a rhombus. And then we have a right angle. It's got a little bit of trace of baby daddy in there. So we can prove that baby daddy is rectangle. So it's a rhombus and a rectangle, so it's going to be a square. So this one is a square. All right, determine whether a statement is true or false. If it's false, rewrite the sentence to make it true. If it is true, then list any other quadrilaterals that the sentence would also be true for. So number 14, diagonals of a rhombus are sometimes perpendicular. Well, on the rhombus, the diagonals are actually going to be always perpendicular. So this would be a false statement. And we don't have to rewrite the whole statement, just change the words or cross it out and put what it's supposed to be. 16, squares inherit all the properties of parallelograms, rectangles, and trapezoids. So squares inherit all the properties of parallelograms, that's true, rectangles, and the baby mama, which is a rhombus, not a trapezoid. A trap on the side, that's something completely different. What did I just say? All right, so cross that one out. It should be a rhombi instead, and that would be false. All right, so on this one, we want to solve for the missing angles. Well, if we look at this triangle we have on the side here, we know, I think on 17 it tells us it's a rhombus, which means that pretty much everything is congruent. The diagonals are going to cut each other in half. So if this is 73 and we have angle 2 and 4, we know these are both the same value x, then we can add them all together. So the 2x plus the 73 is going to be equal to 180 because we do have a triangle, and that'll be how we solve for the value of x on this one. So subtract the 73 from both sides, leaving 2x is equal to 107, divided by 2, and we get x is equal to 53.5. So what we actually know is that all of these angles here will have to be 53.5 because if it's a rhombus, the diagonals are going to cut each other in half. So all the angles 1, 3, 4, and 2 are all going to be 53.5. So those will all be your 4 answers from the answer bank. All right, number 19. So again, it's a rhombus. They tell us in the description of the problems, meaning pretty much everything is exactly the same. So if this is 70 degrees here, that means that all of the angles here are 70 degrees. So angle 3 also has to be 70 degrees. And then we can move that one over here, which is what I forgot to show. And then we know angle 2 has to be a right angle, right? Because the diagonals are always perpendicular for a rhombus. And then if we look at this triangle here, we can figure out the missing angles over here because they have to be 180, right? So the missing part would be 20. And if this one's 20, so is this one over here. We could actually go as far as saying this has to be 70 and both of these over here have to be 20 as well. And in fact, all of these are right angles because rhombuses, property of rhombi. All right, next one we're going to do is 27. So what do we know about the diagonals of a rectangle? Well, for a rectangle, it's a special case where they're actually going to be congruent. So we can set them equal, but on this one, the x is referring to just this part and not the whole thing, where the 6x minus 12 is equal to the whole thing. It's not very clear in the marking, so I went ahead and did this problem with you. So instead of setting them equal to each other, this is only half of that one. That's the whole thing, right? So we can either double the small one or cut the big one in half and then set them equal to each other. Well, I'm just going to double the small one, so I get 2x is equal to 6x minus 12. Then I can subtract 2x from both sides. I get 0 is equal to 4x minus 12. Then I add 12 to both sides and get 12 is equal to 4x. Divide both sides by 4, almost done, and x is going to be equal to 3. So that will be our first answer. And then when I plug it in for QU, well, QU is x, so that's just going to be 3. And then RT is going to be the whole thing, so it's going to be 2 times that amount, right? Because they're the same diagonal, right? So that would be 6. So RT is 6. Now on 33, they say it's a rectangle, and if it's rectangle, then we know the opposite sides are going to be congruent. We also have right angles, but the opposite sides being congruent, that's true for all parallelograms, but we just know that they're not all the same because it's not a square or a rhombus. So all we can do is set the opposite ones equal. And when I do that, I get x is equal to 4y, and 3x plus minus 10 is equal to 2y. But if you notice on both of those, we have 2 different equations with 2 different variables. So we have to do substitution or elimination. Elimination wouldn't be too difficult. We just multiply this by -2 and everything by -2. But it's easier just to do substitution because this one's already solved for x. So what I'm going to do is I'm going to take the x is equal to 4y, and I'm going to plug in 4y in for this x in the next equation. So that's going to look something like this. So 3 times 4y minus 10 is equal to 2y. Then all I have to do is multiply. 3 times 4 is 12y minus 10 is equal to 2y. And then you can solve the rest of the equation here. I think it's just going to be 1. Yeah, it's just going to be 1. So y would, in that case, would be equal to 1. Then you can solve for the rest of them by plugging them back in. So I'll leave you to do that one on your own. So pretty quick on all this. Trying to make the videos as short as possible, but also get through the information. So if you have any questions, please just let me know on Google Classroom, and I'll see you guys later.